Okay, so this is a review on one part of the lesson that dealt with composition of functions. Now, before we look at some examples again, let's remind ourselves about the definition. So basically, when you're looking at composition of functions, you're looking at taking one function, putting it inside of another function. And so the notation is important. So your notation is important. All right, so here's a notation you need to be aware of in this particular case. So when looking at composition of functions, the notation looks like this. So you'll see something like f, and then you can see an open circle like this. So that open circle means composition. It does not mean multiplication. All right, so don't confuse that with combination of functions that you did earlier. So this is composition. So if you see F, open circle means composed with G at X. That's how you read this. So F composed with G at X. Okay? So F composed with G at X, by definition, that means this. See how F is listed first and G is listed second? So look at this first right here. Now, again, don't think that means F composed with G times X. It's not multiplication. Okay, so this at here does not mean multiplication. All right, so don't think that. All right, so by definition, you're going to rewrite this as f of g of x. That's how you're going to rewrite this. So this must be rewritten as this. See how this looks? Your notation's important. Okay, so notation's important. So, so, um, so you read this part. So this part's read like this. So this is how you read that part. And then this part, you're going to say f of g of x. Okay, that's how you read that. All right. Now, so for example, let's see if you can go further with this definition. Suppose you had this h composed with k at x. All right. Do you know how to write this? Make sure you know how to write it. So f composed with k at x is, this is listed first. That goes first. That will be, that will be h of k of x. That's how you write it. Okay. So if you had this first, like this, do you know how to write that? Okay, that's going to be g of f of x. Okay. All right. So that was basically some things you have to remember from previous lessons. Now, let's remind ourselves this example. So let's do this example for a moment. Okay. Suppose you're told, example 1, suppose you're told that f of x is 2x plus 5 and g of x is, let's say, negative 3x. Okay? And you want to find f of g of, let's say, 2. Okay? So f of g of 2. Now, first thing you got to do to find this, now you see how this is a composition right here because you're taking one function, you got to find this. See how this functions inside of f? Okay, so f of, so you're taking g and you're putting it inside of f. So that's what we mean by composition. You're taking one function, put it inside of another. Okay, now to do that though, you got to find this inside first. So you got to do the inside first. I'm using the word inside. So we got to do the inside first. Okay, so I got to find g of 2. So let's go off to the side and find out what g of 2 is. So g of 2 means, you've done that before, you go to the function g. See how you have two different functions. You go to function g, where we see the variable x, you're going to substitute 2. So that becomes negative 3 times 2, which is negative 6. So I found g of 2. So that's this. So this becomes f of, remember I already found g of 2, that's that, so it becomes negative 6. And now you do just like you did this. You go to your function f this time, and where we see the variable x, you're going to substitute negative 6. So I get 2 times negative 6 plus 5, which is negative 12 plus 5, which is what, negative 7? So therefore, your answer, you're going to say this. You're going to say, this is what you're looking for, right? You're going to say f of g of 2 is equal to negative 7. That's what you say. All right? Okay, now let's look at number 2. Supposing number 2, though, I want to find g of f of, let's say, negative 5. Okay? G of f of negative 5. Same idea. You got to look for your inside first. So which one's the inside? F of negative 5. So I find f of negative 5 first. Find f of negative 5. So f of negative 5 means I go to my function f, and where we see the variable x, I substitute negative 5, right? Okay, so I get 2 times negative 5 plus 5, right? Okay, so this becomes negative 10 plus 5, which is negative 5. So f of negative 5 is negative 5. So I found my inside. I found the inside first. So now this becomes g of, I found this, right? That's this. So now all I got to do is find g of negative 5, and there's my answer. All right, so g of negative 5. So now I find g of negative 5. So g of negative 5 means I go to my function g, and where we see the variable x, I substitute negative 5. So it becomes negative 3 times negative 5, which is a positive 15. And so your answer, then, you're going to say this. You're going to say g of f of negative 5 is equal to 15. Okay? All right. Now, so let's call this example 1. That's going to be A, and that's going to be B. Okay? Now, let's suppose in example 2, I had this. All right, example 2. Let's suppose example 2, I had f of x is x plus 7, and g of x is 2x minus 3. Okay? So f of x is x plus 7, and g of x is 2x minus 3. Suppose I want to find, let's say a. Suppose a is f of g of negative 2. Okay, so f of g of negative 2. Based on example 1, based on this example, what's your first step? All right, well, your first step is to find the inside part first, right? So let's do that. So let's go off to the side and figure out what g of negative 2 is. Now remember, to find g of negative 2, you have your two functions. You got to make sure you use the right one. So this says I go to function g, and wherever we see the variable x, I substitute negative 2. So it becomes 2 times negative 2 minus 3. So that's negative 4 minus 3, which is negative 7. So g of negative 2 is negative 7. So I found my inside first. I found this. So this becomes f of negative 7. And then finally, all I do is I go to my function f this time, and where we see the variable x, I substitute negative 7. So this becomes negative 7 plus 7, which is 0. So the answer, you're going to say f of g of negative 2 is equal to 0. Okay? B. Now let's suppose I had this. Let's suppose I want to find f of g of x this time. So f of g of x. All right, now notice when I did example 1, see how I was substituting numbers into my variables? See how I was evaluating these at numbers, and I ended up with a number, right? With a real number. Negative 7, 15, 0. Here, though, you don't see a number here, like you did negative 2, like you did negative 5, like you did like you did 2, right? Okay, well, no big deal. I can handle this. So remember, do the same thing. You look at the inside first. Well, what's the inside? Well, the inside is g of x. All right. Here we said the inside was g of negative 2. So I had to actually figure out what g of negative 2 is. I had to actually figure out what f of negative 5 is. I had to figure out what g of 2 is, right? Here, though, there's no figuring out. You know what g of x is. G of x is this function right here. So then you go and you say, all right, well, I know that g of x is this, so that means I'm going to replace this just like I did here. What's I figured out? I replaced g of negative 2 with negative 7. I replace f of negative 5 with negative 5. I replace g of 2 with negative 6. So this has replaced g of x with what it equals to. It equals to this. So this becomes f of 2x minus 3. And then you had this in a previous lesson. So how do you figure out what f of 2x minus 3 is? Well, you go to your function f, and where we see the variable, you substitute 2x minus 3. So I'm going to go ahead and rewrite it over. So f of x is this, right? So this says I go to my function f, where we see the variable, I substitute 2x minus 3. So this becomes, remember, you may want to, if you need to, you may want to kind of circle this. So you're going to replace what's being circled with 2x minus 3. So it becomes 2x minus 3 plus 7. Combine like terms, that's 2x plus 4. And so therefore, your answer is f of g of x is 2x plus 4. And that's your answer. So notice that in the previous problems, you ended up with a real number. Here you end up with an expression, a variable expression, because you are substituting a variable expression, and your inside function ended up being a variable expression. Okay? All right, number 3, letter C. Suppose I want to find this. Suppose I want to find g of f of x. G of f of x. All right, well, by definition, g of f of x says I do this. I find the function, the inside function first. Well, this time, f of x is this, right? So it becomes g of x plus 7. All right, and then I do this like I did in the previous lesson. You go to your function g. I'm going to go ahead and rewrite g. And this is my function g, right? And so that says wherever we see the variable x, I'm circling that x right here. I'm going to substitute x plus 7. That's what that says. So this becomes 2 times, put that in parentheses. Remember we talked about that in the previous lesson. 2 times x plus 7, and then minus 3. So notice, read it out. This is my function g, right? You're looking at function g. 2 times your variable, minus 3. So 2 times my variable expression, minus 3. All right, distribute. I get 2x plus 14 minus 3. So that's 2x plus 11. So therefore, g of f of x is 2x plus 11. All right? Okay, example 3. All right, let's suppose in example 3, I have this. All right, example 3. Suppose in example 3, I have f of x is 2 minus 3x, and then g of x is x minus 5. Okay? All right, now, let's suppose I want to find this. Find a, and I'm going to go ahead and write out what I want to find. All right, now notice that this is a different notation. This is a different notation from these notations, right? Okay, so, but you got to remember, you have to remember what this means. So what does that mean? Well, that means this. So that means that this is going to be f of g of 3. And now that looks like example 1 and example 2. Okay? So then that means then is I find the inside first. So I got to find g of 3. Well, remember g of 3 means I go to my function g, and where we see the variable x, I substitute 3, right? So that becomes 3 minus 5, which is a negative 2. So I found g of 3. So g of 3 is negative 2. All right, so that's what this is right here. So that becomes f of negative 2. And so now this says I go to my function f, and where we see the variable x, I'm going to go ahead and write it over. So here's my function f. And so now, where we see the variable x, I'm going to substitute negative 2, right? So that becomes 2 minus 3 times negative 2, which becomes 2 plus 6, which is 8. So therefore, your answer, you're going to say f composed with g at 3 equals 8. That's what you say. All right, B, still using those same two functions. Let's suppose this time I want to find g composed with f at, let's say, negative 1. G composed with f at negative 1. Well, you got to use your definition. By definition, and remember I'm talking about this, by definition, that means g of f of negative 1. That's what that means. So we do it just like we did before. So you're going to find your inside first. So let's go ahead and figure out what f of negative 1 is. So I'm going to go ahead and write f of x. So f of x, remember, was 2 minus 3x. Okay? And so now where we see the variable x, you're going to substitute negative 1. All right, so this becomes 2 minus 3 times negative 1, which is 2 plus 3, which is 5. So I found f of negative 1 to be 5. So that goes here. So now I want to find g of 5. And so that says I go to my function g, which we know is x minus 5. So I'm going to go ahead and rewrite this. And that says wherever I see my the variable x, notice I'm circling it. Wherever I see the variable x, I'm going to substitute 5. So this becomes 5 minus 5, which is 0. So therefore, your answer, you're going to say g of f of negative 1 is equal to 0. Okay? All right, letter C. Suppose in C, I want to find f composed with g at x. F composed with g at x. Well, by definition, that means this. You got to use your definition. By definition, that means f of g of x, right? Okay. Now, do y'all see that kind of looks like this right here? This right here. All right. So that was in example 2. All right. So let's use that idea. So f of g of x. All right. So this time, I got to figure out what my inside function is. My inside function is g of x. I know g of x. G of x is x minus 5, so that goes here. So it becomes f of x minus 5, right? And so now that says I go to my function f. I'm going to go ahead and rewrite f over. And so here's f. And this says wherever I see the variable x, I'm circling it. I'm going to substitute this. And so now this becomes, notice equal, all these are equivalent. All these are equivalent. All of these are equivalent. Make sure you do it like this. Make sure you do steps like this. Okay, it makes the understanding a little bit better. This is the same thing as this, the same thing as this, the same thing as this, the same thing as this. Okay? This expression is the same thing as this expression, the same thing as this expression, the same thing as this expression, and so on. All right, so this becomes 2 minus 3 in parentheses, x minus 5, because that's what I'm substituting to x. See, 2 minus 3 times your variable. 2 minus 3 times the variable, so my variable, I'm going to substitute x minus 5. Distributing, I get 2 minus 3x plus 15, and then this becomes negative 3x plus 17. And so your answer then would be f composed with g at x is negative 3x plus 17. All right, example 4. Let's suppose in example 4, I had this. Let's suppose that h of x is, let's say, 3x squared minus 2x. And then g of x, let's say, is 5x minus 1. All right? Okay. Letter A. Let's go ahead and find h composed with g at, let's say, negative 4. F composed with g at negative 4. Well, what is the definition? You got to use your definition. But by definition, that means h of g of negative 4. Okay? So now I do the inside first. So I got to find, notice I'm going off to the side. So I got to find g of negative 4. So g of negative 4 means I go to my function g, where we see the variable, I substitute negative 4. So that becomes 5 times negative 4 minus 1. So that's negative 20 minus 1, which is negative 21, right? Okay, so that's what this is. So it becomes h of, so now I'm going to replace the inside with what it's equal to, negative 21. All right, now you need your calculator with this, because I didn't realize this was going to be, the absolute value of this was going to be large. Okay, so now we're going to go to your function h. So this says now I go to my function h. I'm going to rewrite h of x here. And this says wherever I see the variable x, and I see it twice, I'm going to substitute negative 21. So now this becomes this becomes 3 times, in parentheses, negative 21 squared minus 2 times negative 21, right? And so using your calculator, let's see what we get. So negative 21 times itself, negative 21 times a negative 21 is 441, right? Times 3 gives us, so this right here is 1,323. And then a negative 2 times a negative 21 is a positive 42. So I'm going to add 42 to that, and I get 1,365. So therefore, your answer, you're going to say H composed with G at negative 4 equals 1,365. All right, letter B. Suppose I want to find G composed with F, let's say at 2. G composed with F at 2. All right, well, again, definition. You're going to rewrite this as G of F of 2. Notice the order. The order matters. Okay? And so this says I go to my function F. I do the inside first. So here's my inside. So this says I go to my function F. Wherever we see the variable, oops, I'm sorry, did not mean F because there's no F here. So let's say G composed with H, because those are your two functions, H and G. I'm sorry. That's H. So I go to my function, so I want to find H of 2. So this says I go to my function H, which is here, and let me go ahead and rewrite this. So it's 3x squared minus 2x. And where we see the variable x, again, it helps if you circle it. You're going to substitute 2. That's what that says. So then this becomes 3 times 2 squared minus 2 times 2. So 2 squared is 4. 4 times 3 is 12. And then 12 minus 4 is 8. So that's H of 2. So that's what this is now. So you replace the inside function with what it's equal to. So remember, this is the same as this, the same as this, and so on. So this becomes G of 8. And so G of 8 says I go to my function G, and where we see the variable x, I substitute 8. So that becomes 5. Let me do it here. 5 times 8 minus 1. So that's 40 minus 1, which is 39. And so therefore, G composed with H at 2 equals 39. All right, what about C? Suppose this was C. Suppose in C you want to find G composed with F at X. I keep saying F because there's no F here. Let's say H. Okay, so G composed with H at X. Well, by definition, that means G of H of X. Okay. Now, before we go on, I want you to remember this. See how I'm evaluating this composition at a real number? I ended up with a, where is it? Right here. I ended up with a real number, right? I'm evaluating this composition at a real number. I ended up with a real number. Here, I'm evaluating this composition at a variable. I'm going to end up with a variable expression, just like we did in this letter C of example 3. See, I ended up with a variable expression. Keep that in mind. All right, so this says, remember, just like we did before, this says I got to look at my inside function first. Your inside function is H of X. Well, H of X, remember, is this. H of X is 3x squared minus 2x. So I'm going to replace that with this. So now I want to find G of 3x squared minus 2x. So now remember what that means. That means I go to my function G, which is this, and wherever I see the variable x, which is this, I'm going to substitute this expression. That's what that says. So then I get 5 times 3x squared minus 2x. If I see 5 times your variable, I'm substituting this in my variable, so 5 times your variable, and this is your variable expression now, and then subtract 1. And so now distributing, I get 15x squared minus 10x minus 1, and there's nothing else you can do. Those are not like terms. So therefore your answer, G composed with H at x, is going to equal 15x squared minus 10x minus 1. And then finally, let's look at D. Suppose I want to find H composed with G at x. H composed with G at x. Well, by definition, that means H of G of x. And so then I go and I find out what g of x is. Well, g of x is this right here. So I'm going to replace the inside with what's equal to. So h of 5x minus 1. All right, and this says I go to my function h. And remember, h of x is this. And this says wherever I see the variable x, I'm circling them, I'm going to replace it with this expression. All right, now this is going to involve a lot more work than this one did, because notice you're squaring a binomial. And remember, that's a little bit more work. All right, but let's still go ahead and write this out. So remember, all these are equal. So that becomes 3 times 5x minus 1 squared minus, see, 3 times your variable expression, which is this, squared. Subtract 2 times your variable expression, and I'm going to substitute that with this. Okay, now we got to do some work. So let's figure out what, first of all, 5x minus 1 times itself is. So 5x minus 1 times 5x minus 1, because that's what this is. You got to do this first. You got to do your exponents first. So when you use a full method, you're going to get 25x squared. The outer and the inner is going to be a negative 10x, and then the last is a positive 1. So that goes here. So that's what we just found. But all that has to be multiplied by 3. So you can say 3 times this trinomial. 25x squared minus 10x plus 1. And then this problem is just go ahead and distribute the 2 here, negative 2. So it'll be negative 10x plus 2, right? Okay, now distributing the 3, I get 75x squared minus 30x plus 3 minus 10x plus 2. And then combining like terms, I get 75x squared. A negative 30x and a negative 10x is a negative 40x. 3 and 2 is 5. And there's your answer. And so therefore you're going to say h composed with g at x is going to equal 75x squared minus 40x plus 5. Okay? So that was a quick review on how to evaluate composition of functions. On given a composition of function, how to evaluate it at a numerical value, and also how to evaluate it at a variable expression. Okay? All right, so that is a review of composition of functions.